Hey guys, this is Mr. H. Hey, I am going to do a video on linear regressions and correlation coefficient. I'm going to start with this image. I have to say this. Part of the reason I'm doing this is as a class, we did not do particularly well on the linear regression that came up on the June 2024 Regents exam. It's a 4-point question, and on average, we got about 3/4 of a point. So it was about 0.75. And that's not very good. If there are 4 points and we're averaging less than a point, then we're leaving a lot on the table. So what I wanted to do with this video is I wanted to go through correlation. I wanted to explain that. I also wanted to show you how to come up with the linear regression and also how to come up with the correlation coefficient. I'm going to do several examples. I'm going to do one example in this video, and then I'm going to do a bunch of linear regressions and make a playlist so that students who are struggling can watch that and kind of understand what needs to happen. All right, so let me go. So here are the things that you need in order to do well with linear regressions. First of all, you need to know how to use your graphing calculator. There is almost no way to come up with a linear regression unless you use your graphing calculator. So you have to know how to use it. So I'm going to show you how to do that. You also have to be able to round because almost all linear regressions are going to involve some rounding decimals. So you got to be able to round. And unfortunately, a lot of students struggle with that. Third, you, at least for the way I'm going to show it, you have to be able to take the square root of a number because that's going to be how we find the correlation coefficient. And then you need to know what correlation means and how to explain it. So I'm going to start by explaining correlation coefficient, and I'm going to start with this image right here. All right, so what you see on my screen is a kind of a collage of images, but the idea is this. This is a coffee shop, and a coffee shop sells coffee. It sells hot chocolate. This is a glass of hot chocolate, or a cup of hot chocolate with some marshmallows. And now I'm going to explain the idea of correlation by looking at this image. So she's out running, and you can see that it's pretty warm because she's wearing pretty much just some jogging outfit. So this is a hot day, and this is the desert, which is also pretty hot. Now, this is how I'm going to explain correlation. If you owned a coffee shop, what do you think would happen to the sales of hot coffee and hot chocolate during the summer? If you said the sales will go down, you'd be right. And the reason is very few people want to drink hot beverages on a hot day. They'd rather drink something cold on a hot day. So what you would say is that there is a correlation between the temperature outside and the number of hot beverages you sell inside. So that's what correlation means. In this case, it's a negative correlation. So when the temperature goes up, the sales of hot chocolate and coffees go down. So they're going in opposite directions. That is called a negative correlation. Now, on the other side, if the temperature goes down, like it gets really cold, what do you think happens to the sales of hot chocolate and hot coffee? It's going to go up. So again, they're going in opposite directions. So that's a negative correlation. All right, so that's correlation. It just means there's a relation or connection between two variables. And what we're going to be trying to do is we're going to try to determine the strength of the correlation. So here are some scatter plots. And basically, this is the line of best fit. You can see that this is a positive slope, so that's a positive correlation. This is a negative slope, so that's a negative correlation. This has no slope, so this would be no correlation. So this is a positive correlation. This is a negative correlation. Now, this one is a negative correlation, but you can see that the dots the scatter plot is tighter around the line of best fit. This means this has a higher correlation, a stronger correlation. This one has a correlation, but it's not as strong as this one. So the more dots, the closer that the dots are around the line of best fit, the stronger the correlation. The more spread out it is, the less of a correlation there is. And of course, this is no correlation. All right, that's it. Now, to quantify correlation, you would say if it's negative, the highest or the lowest value you could have is a -1. If it's a positive correlation, the highest value you can have is a +1. So correlation is always going to be between a -1 and a +1. It can't be a -5.6. It can't be a +10.1. It has to be between a -1 and a +1. All right. Now, if it is, the closer it is to a -1 or +1, the stronger it is. And the closer it is to 0, the weaker it is. So if you have a correlation that is 0 or perfectly 0, that means basically there is no correlation. Okay? And the closer it gets to 1 on either direction, the stronger it gets. So let's go. Now, here is a question from the January 2016 Regents exam. And I'm going to read it, and then we're going to do it together. It says, Erica is the manager of Stellar Beans. She's collected data on the daily high temperature and revenue from coffee sales. She's collected data from 9 days this past fall, and it's shown in the table below. So you see temperature and you see coffee sales. We've already talked about this. Temperature and coffee sales are going to go, it's going to be a negative correlation because they work in opposite directions. Now, so we're going to take this table and we're going to input that into a spreadsheet, and then we're going to find the linear regression. So what we're trying to do is we're trying to find a linear regression f of t that estimates the day's coffee sales with a high temperature of t. Record all values to the nearest integer. So we have to round all of our coefficients and our constants to an integer. And then the second part is we are going to state the correlation coefficient, which is R, to the nearest 100. And we got to indicate, is it strong, positive, strong, negative? Is it moderate, whatever? So we're going to do that as well. So now let's jump into it. So right now I'm going to grab the calculator and I'm going to show you what we need to do. Now I've already entered this data into the spreadsheet. And the reason I did that is I didn't want to waste the time actually just putting these numbers in. But this is all you have to do. You're going to just enter, and I made this X column called temperature. I made the Y column called sales, and I just entered the data. Now what I'm going to do is I am going to press the home screen. I'm going to go to this data and statistics, this little bar graph right here. And it's going to give me 9 dots. That represents the 9 days of data that we collected. Down at the bottom, I'm going to put the X value, which is temperature, X variable. And then over here on the Y-axis, I'm going to put the Y variable, which is sales. Now, here is the scatter plot. Now, this is not a perfectly correlated thing, but you can see that this is basically a negative sloped correlation. Now, we're going to find the actual line of best fit, and the way we do that is we go menu, we go analyze, we do regression, and then we do linear, show linear. And you see it's in the mx plus b slope intercept form. So here is our equation. And remember, we've got around these the slope and the y-intercept to integers. So if we're doing that, you have to look at 8 is in the ones place. So we're going to look to the right. It's a 2. So 4 and below, you just let all of this stuff go. So we're going to drop all the decimal parts. So it's just going to be a negative 58. And then, of course, you've got to multiply that times x in order to get, you need the x. And then the y-intercept is going to be same thing. We go to the 2 that's in the ones place. We look to the right. There's a 1, so that's 4 below. So we're just going to drop all of the decimal part, and it's going to be 6,182. So I'm going to go here and I'm going to write that. So it's going to be y. Actually, it's not y. It's f of t, because they want us to write it as a function. So it's going to be f of t equals a negative 58. We rounded it. And instead of using x, we're going to use t, because that's the variable we're supposed to use. And then the y-intercept is going to be 6,182. So if we go back, you can see that that is the rounding, right? Now, the key here is that the slope is negative. This is a negative slope. So we know that our correlation coefficient, we may not know the actual number, but we know it's got to be negative. In fact, I'm going to put it there so I don't forget it. Now, let's go. To find the correlation coefficient, all we're going to do is we're going to take the r squared value, and then we're just going to take the square root of this, because that's going to give us the correlation coefficient. So let me show you exactly what we're doing. So I'm going to write this number on my iPad. So it's 0.891382225. Actually, that's enough. You don't have to write all the numbers. I think that's enough. So I'm going to go here. I wrote the r squared. Now, to find the correlation coefficient, all I'm going to do is I'm going to take the square root of this number. So now I need the calculator again. So I'm going to go to this, and I'm going to do square root. And inside there, I'm going to type in that r squared number. So it's going to be 0.891, what is it? 1, 3, where's 3? 8, 2, 2, 5, 3. So now all I'm going to do is press enter. So here is the correlation coefficient. And remember, we have to round this to the hundredths place. So if I go here, if you look at the first 4, that's in the hundredths place. So we're going to look to the right, and that's 4 below. So we're just going to drop all of this stuff, and we're going to leave it as 94 cents. So on my exam, I would write 0.94. Now, the last thing I need to do is I need to state what's the relationship. This relationship between the temperature and coffee sales is a strong negative correlation between the temperature and the coffee sales. All right, so now let me show you how this would be graded. Having this equation rounded properly would get you 2 points. Then stating the correlation coefficient rounded properly would be 1 point. And then saying this would also get you 1 point. So now what I'm saying to you guys is that we have to be able to get at least 3 out of 4 of these points. We need 75% of the points. 3 out of 4 should be our goal. Okay. Everything in here, once you just type in your data into the spreadsheets, it's going to basically give you the equation. You just have to round it. And then you take the r squared and take the square root of that and round it to whatever they tell you. Normally, the correlation coefficient is almost always rounded to the hundredths place. So that should be 2 decimals. It should be clean. You just got to pay attention to the sign, because that's going to tell you whether it's going to be a positive correlation or a negative correlation. All right, I'm going to stop this and I'm going to post it. And then I'm going to do a couple of more examples, and I'm going to put this in a linear regression playlist for you guys to look at and try on your own. All right, so I'm going to stop and pop.